Hello again, folks. Welcome to the second part of our Unit 5 test review. And we're going to do 5 questions. They are all the free response questions. So none of these would be multiple choice. So we're going to have to answer them best of our ability, just freestyle, just right. So let's start with number 16. Number 16 says this: in order to estimate the proportion of families that are in favor of changing to the current school year to year-round schooling, school district administrators randomly sampled 300 of the families in the school district. Only 86 of the surveys were returned, but 23% of the surveys indicated that the family was in favor of switching to year-round schooling. What type of bias might affect the results of the survey? Well, they sampled 300, but they only got back 86. That's a clear indication of a non-response bias. Non-response bias. We could see that because remember, 86 responded. That's 214 didn't respond. All right, now part B, a little weird on this question. Is the sample proportion likely to be an overestimate or an underestimate of the actual proportion of families that are in favor of year-round schooling? This one actually, you can kind of say it either way because there's really no clear indicator of whether it would be over or under. So it could be over if the people who don't respond are the ones who are in favor of keeping it the same. But it could be an underestimate if the people who didn't respond are the ones who are favoring the switch. So it kind of just depends. We don't really know which way people are going to lean. So I'll say it could be underestimated if the families who didn't respond would prefer switching to year-round schooling. Because what we're saying there is that there's more people out there who would prefer the switch than the 23%. But again, it could be the other way around. It could be an overestimation of the people out there, the ones who don't prefer to switch. Part C, what can the school district do to address the bias concern in part A? Well, to fix non-response, you got to get people to respond, right? So they can either call back or or just reach out in general, or reach out to get them to respond. All right, number 17. Elementary schools in rural India are usually small with a single teacher. The teachers often fail to show up for work. Here is an idea for improving attendance. Offer the teacher better pay for good attendance. Give the teacher a digital camera and with a tamper-proof time and date stamp and ask a student to take a photo of the teacher in class at the beginning and end of the day to verify attendance. Will this work? Researchers obtained permission to use 120 rural schools in Rajasthan for an experiment to find out. Explain why it is necessary to include a control group that doesn't get a financial incentive. All right, so all that just to say why we need a control group. We need a control group. Control group is needed to provide a baseline to see if increased pay, hold on one second. Right. Sorry for a second, I got a little interrupted. Yeah, so provide a baseline to see if increasing pay um will increase attendance. For sure. Okay. All right, number 18. An experiment is conducted to see if a new type of rubber used um for a shoe's sole will last longer than the current brand. 60 door-to-door walking mail carriers have volunteered to be part of the experiment. 30 of the carriers will be given shoes with the new sole, and 30 will be given shoes with the current sole. After 6 months, the average wear of the shoe sole will be calculated for both groups. Describe how the researchers could carry out the random assignment of the two different types of rubber using slips of paper. So you could have 30 slips, say old, or just a current, I guess. Current, and 30 slips, say new. Have all 60 people choose one from a hat. Forgot to say it should be mixed together. With slips mixed together. Kind of adding that at the end here. All right. That's gonna do that, I think. Yeah, so slips of paper, right? You should have some 30, let's say current. You can say even A and B, as long as you know what A and B represent. A can be the current, B can be the new ones, whatever. But have 30 that say one thing, 30 that say the other, and have them mixed up and randomly selected from each participant. Why is it important that the researcher randomly assign treatments to the subjects? Remember, the whole reason for this is to create two roughly equivalent groups. And the reason for that is to help avoid confounding. So it's to help avoid confounding by creating two roughly equivalent groups. All right. Explain why it's important to have all volunteers be door-to-door mail carriers. I mean, to be sure, both, I guess, to be sure, each person gets an equal amount of walking. And it's not going to be equal exactly, but the fact that everyone's going to be walking a lot, if that makes sense, you can probably word that a little bit better. But the fact that they'll be walking a lot, you're not going to have some people who like, walk like 10 steps a day, and then people who are walking 10,000 steps a day. Like these are all people who are going to be walking like 10,000 steps a day. So you get a lot of kind of mileage on these shoes, and that's good for it. And again, it's everybody's going to be walking a lot. It's not like I said, some people will walk very little. Everybody should be walking a lot. All right, number 19. An experiment was conducted to determine if a new weight loss formula worked better than exercising when people wanted to lose weight. 16 volunteers were placed into different groups. Group A was given the new weight loss formula, and Group B met 5 days a week at a gym to exercise for an hour each day. After 6 months, the weight loss to the nearest pound of each volunteer was measured. The results in the table listed below. Draw an outline for this completely randomized experiment. Okay, so we start with 16 volunteers. And then we're going to randomly assign them. And then there's two groups. We got the group one shall have 8 people. Group two, which will have 8 people as well. Group one will be the formula, treatment. Group two will be the second treatment. They will do the exercise. And then in the end, we compare results. Compare what specifically? Compare weight loss. All right. Calculate the mean weight loss for each group and the difference in means. We have a little bit of math on this one, which is nice. So the mean weight loss for formula. So formula mean is, I've already done it. But if you add these all up, 19 plus 22 plus 20, etc. If you add these 8 numbers up for formula and then divide by 8, you get 17.5. And if you do the same thing for the exercise, the average for the exercise values is 14.5. So then the difference, formula minus exercise, is 17.5 minus 14.5, which is 3. So basically the formula lost 3 pounds more on average than the exercise group. Using the data above, 100 trials of a simulation were performed to see what differences in means are likely to occur due to chance variation and random assignment. Assuming that the plant food doesn't help plants grow. Wait, did I copy the right question here? I don't think I copied the right question. Or maybe I did, but it might have been, yeah, I didn't copy the right question here. This should be about the weight loss. I don't know if that's a typo. Hold on, let me check 1 second. Hold on. Give me pause. All right, to prove it's not my fault, that I'm not crazy, here's the original question. This comes from the question bank, by the way, that I've used to make the test. You can see that it's right here. Talking about plant food, helping plants grow. We have seen this before, but it's not supposed to be here. So this should have been revised. It should be reworded. So anyway, just wanted to prove it wasn't my fault. Oh, wait. No, this is a plant food question. Hold on. Oh, nope, still here. Right. As you can see, it still says it. What differences in means are likely to occur due to chance variation? Assuming plant food doesn't help plants grow. Again, yeah, so this is the gym one, and these are the plants. Again, I don't know. I didn't do this. It's not my fault. It's still wrong. Either way. We do have the right graph though. That's all that matters. Let's go back to that. So basically, ignore that. We have 100 simulations where we're looking to see that formula and exercise are no different from one another. And we have the results below here. It says, use the results of the simulation below to determine if the difference in means from part B is statistically significant. So the difference in means was 3. And if we look at the chart here, remember there's 100 dots. So out of 100 simulations, there was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I don't know if you can see that. I'll zoom in. Can I zoom in? Yeah, there it goes. There were 8, 9, 10, 11, 12 dots that were 3 or larger. So 12 out of 100 simulations where we got a similar result. And so since that is less, or I'm sorry, that's more than 5%, right? That's 12%, right? So since 12% of simulations had a value of 3 or higher, the difference is not statistically significant. Because remember, it has to be 5% or less to be statistically significant. All right, last question. Are people who report being cheerful and happy less likely to get sick than people who report being sad and angry? Yes, according to a study where researchers exposed 193 healthy volunteers aged 21 to 55 to a cold virus and recorded who got sick. Cheerful people also had milder symptoms when they did get sick. Based on this study, is it appropriate to conclude that being happy and cheerful reduces risk of catching a cold? Well, no. And the reason why here is because this is more of an observational study than an experiment. And when you have that, these individuals are not randomly assigned. You can't have a causal relationship. You can't say that this being happy and cheerful causes a reduction in cold unless you have random assignment. There's nowhere in this problem are we randomly assigning these volunteers to a cold virus or not a cold virus, or, I mean, there's just isn't a way of doing that. So no, this is an observational study. We can't establish causal relationship unless we have an experiment with random assignment. All right, that's gonna do it. Little hiccups there, but I think we're good. That's it. So hopefully this helps. Hopefully you can review this. If you have questions, let me know in class or just email me. That's fine too. But I want you guys best of luck. And yeah, I'm here if you need anything. So I'll see you next time. Bye for now.